Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, refreshed and inspired. And if you like my videos, if they are important to your studies, please don't forget to subscribe. By the first method, determine the support reaction RB. EI is constant. So here's the figure, and this time we'll solve for the reaction at B by the conjugate B method. So let's make B the moment center. First, let's remove support B so that the beam becomes determinate, and we can find the deflection at B as shown. So from here, we can solve for the reaction at A, and it is 1065 over 7. So reaction at A times 14 equals 50 times 3 plus 30 times 6 times 11. So you can find that 1065 over 7. Likewise, R sub C is 545 over 7. So I will leave that to you to check by statics. Then this is the equivalent conjugate beam. It remains roller at the left end, pin at the right end. And let's have this as our moment center. 1065 over 7 times 6 is equal to 6390 over 7 over EI, but EI is constant. So let's just assume EI equals 1. Then moment of the 545 over 7 times 8 is 4060 over 7. Moment of the uniform load, second degree, it is 540, 30 times 6 times 3. And moment of the 50 kilonewton load, 50 times 5, 250 as shown. So first, let's solve for theta A, and that's theta C. So by conjugate beam methods, we sum up moments about C0. So theta A times 14 plus the moment of this area, quantity 0.5 of 6 times 6390 over 7. 1/3 of 6 is 2 plus 8, so 10. Moment arm is 10. Plus the moment of this area with respect to C, plus 0.5 of 8 times 4060 over 7. 2/3 of 8 is 16/3. Minus the moment of this second degree curve area. So 1/3 of 6 times 540. 6 over 4. 6 over 4 is 1.5 plus 8, so 9.5. Then minus 1/2 or 0.5, sorry, plus 0.5 of 5 times 250. 2/3 of 5 is 10/3 plus 3. The moment arm, 0.5 of 5 times 250 times 10/3 plus 3. So from here, we can solve theta A equal to negative 1889.643 over EI. So let's go back, divide it by EI. Having found theta A, we can now solve delta B. So that's theta B positive, delta B counterclockwise positive. So summation moment about B0 considering AB. So delta B plus moment of this area, which is 1/3 of 6 times 540 times 1.5, or 6 over 4, equals theta A, which is negative 1889.643 over EI times 6. Then plus moment of this area, 0.5 of 6 times 6390 over 7 times 2, where 2 is 1/3 of 6. So delta B can now be computed. Negative 7480.715 over EI. Now for FBB, so we apply unit upward load at B, causing it to deflect by FBB. Then by steel conjugate beam method, let's compute the reaction here. Downward reaction here times 14 equals 1 times 8. So 8 over 14 is 4 over 7 downward. So this is 3 over 7 downward. So since we make B as our moment center, the moment diagram or the loading for the conjugate beam would be 4 over 7 times 6, 24 over 7, 3 over 7 times 8, so 24 over 7 as shown. Then let's solve for theta A prime. That's theta C prime. So summation moment C0, theta A prime times 14 equals 0.5 times 6 times 24 over 7, moment arm 10, 2 plus 8, then plus 0.5 of 8 times 24 over 7, 2 thirds of 8 is 16 thirds. So theta A prime equals 8 over 7 EI. Then let's have theta B and FBB. The moment is FBB, theta B prime. So to solve for FBB, we sum up moment about B considering AB. So from the figure, FBB plus 0.5 of 6 times 24 over 7 times 2, then equals theta A prime equals 8 over 7 EI times 6, or just ignore EI. So FBB equals 384 over 7 EI. The compatibility equation, FBB RB plus theta A prime, or delta B equals 0, sorry, or delta B is equal to this. So FBB 384 over 7 RB, we cancel EI, then plus negative 7480.715 equals 0. So from here we can solve RB. R sub B equals 136.367 kilonewtons. So this problem is also solved by the principle of the method of least work, and verify that the answer is the same.